Hello students, here is the question which is asked. Let's read the question. This question was asked in a JEE Main 2019. In which of the following process the bond order has increased and the paramagnetic character has changed to a diamagnetic character? See, this question is based on molecular orbital theory. I'll give you a simple example. If it is a hydrogen, if it is a hydrogen molecule, if it is a hydrogen, this is hydrogen, it is forming a H2. Hydrogen will have a atomic orbital as 1s. Over here it is 1s, and this is also 1s. Here there is one electron and here there is one electron, so there will be a anti-bonding molecular orbital form and the molecular orbital form. So number of the molecular orbital form will be equal to the number of atomic orbital getting combined. Here there are two atomic orbital getting combined, and here the um, molecular orbital form is two. One is anti-bonding, one is bonding molecular orbital. So here if you see, there are two electrons, so first the electron will go to the lowest orbital. This is the one, this is called as a anti-bonding this is called as bonding molecular orbital. Bonding molecular orbital. And this is called as a anti-bonding molecular orbital. Anti-bonding molecular orbital. This is of the high energy, this is of the comparatively high energy, higher energy, and this is of the low energy. Okay, this is of the low energy. So this is the case. So there is something called as a bond order. Bond order is tells about the how many atoms are connected. Like it tells about the atoms are connected by how many bond. Like for example, hydrogen is connected to hydrogen by single bond. Oxygen is connected to oxygen by double bond. This means a bond order is two. Here bond order is one. Nitrogen, when it is connected to the nitrogen, it is a bond order is three. So this is what the bond order is actually. If you want to see the bond order over here, then the bond order is given as number of electrons in the bonding minus number of electrons in the anti-bonding divided by 2. So number of the electrons in the bonding over here is 2 minus anti-bonding is 0 because there are no electrons in the anti-bonding orbital, molecular orbital. So divided by 2, which will be is equal to 1. Let's take a case whether, like, this theory also tells about whether the particular molecule will exist or not. Let's talk about the helium molecule, whether helium He2 molecule will exist. He2 is this helium, and the helium, and here instead of 1s1 it will be 1s2. So there will be two electrons which will be going over here, and the bond order for this will be 2 minus 2, right, which will be is equal to 0. So helium 2 molecule bond order is equal to 0 means helium 2 molecule does not exist. That is what it tells. Now coming to the question, question says that a bond order has increased and the paramagnetic character has changed to a diamagnetic, paramagnetic to diamagnetic. So if any of the orbital, that is a bonding molecular orbital and the anti-bonding molecular orbital, has one unpaired electron, even if there is one unpaired electron, it is called as paramagnetic. And if all the electrons are paired, then it is a diamagnetic. That is what we have to check. One more thing, students, if let's do it for the nitrogen and the oxygen, NO molecule. Let's do it for the first. So let's do it for this NO molecule. NO molecule is consist of nitrogen and the oxygen. If you see the electronic configuration of the nitrogen, it is 1s2, 2s2, 2p3, and the oxygen is 1s2, 2s2, 2p4. Like this is what the electronic configuration of the oxygen will be, right? Total number, see, we have to take care of a total number of the electron. Why it is, I'll tell you after some time. Like total number of the electron is 7 and 8, right? 7 and 8 is, it comes to 14 electron system. This whole molecule comes to the 14 electron system. We are going to put the orbitals in the increasing order. Like here I will put, first I will put, this is to be 1s, this is my 1s orbital of the oxygen, and here 1s orbital of the nitrogen. So it is going to give me a bonding and the anti-bonding. See, in the case of 1s orbital, there are two electrons in the case of nitrogen, and in the case of oxygen. So two will go to the bonding, anti-bonding, and two will go to the anti-bonding. This is called as sigma bonding, like s- sigma s orbital, right? And sigma star s orbitals. This is sigma s2 orbital, right? Then there comes 2s orbital. This is 2s and this is 2s. So there are two electrons in the case of both the cases. So here also there is a bonding and there is anti-bonding. So there will be a two electrons over here and two electrons going over here. Then when it comes to the p orbital, it is this way. It is this way. P orbital means it is this px, py, and pz. So in the case of oxygen, there are four electron. In the case of oxygen, there are four electron. One, two, three, and four. Right. In the case of nitrogen, there are three electron. One, two, and three. So this system, like whole system, NO molecule system, is of it is more than 14 electron system, like 7 and 8. Like it is 15 electron system. See, whenever it is a 15 electron system, uh, the pattern, the orbital orientation will be this way. Okay, orbital orientation will be this way. It will be 1, 2, 2, and 1. Hope you are understanding. 1, 2, 2, 1. And if it is less than 14 electron system, if it was like a N2 molecule itself, then this would be a 2, 1, 2, 1. 2, 1, 2, 1. Like it represents this way. So since it is more than 14 electron system, you can remember this. Like if it is 2, if it is if it is less than or equal to 14, then it is 2, 1, 2, 1, right? Less than or equal to, when it is less than or equal to 14, it is 2, 1, 2, 1. And when it is more than 14, then it is 1, 2, 2, 1. Means this pattern. I mean, you can remember it this way. Like this is more than 14 electron system, right? More than 14 electron system. So this is 1, 2, 2, 1. Okay, I'll go into the more detail of this. This is px, this is py, this is pz, this is also px, py, and the pz. Like there will be always a sigma bond which will be along forming along a z-axis, sigma pz. We can write it this way, sigma pz, or it is 2p, no? Sigma 2pz. Like this is pi x and y. This sigma 2px and sigma 2py. This will be sigma star 2px. This is sigma star 2py. This is sigma star 2pz. Right? This is how it represents. So, like distribution. Finally, we have to go to the distribution, how the electrons are going to be filled over here. And here there are total 4 and 3, 7 electrons. So, what is going to happen over here? It is this 1, 2, 3, 4, 5, 6. The seventh electron will go to this anti-bonding. Now the bond order for NO will be what? Bond order for this NO will be bond order for NO will be number of electrons in the bonding. Number of electrons in the bonding is what? This is bonding and this is bonding, right? 4, and this is bonding. So how much it comes to 10, right? So number of electrons for the bonding is 10 minus anti-bonding is how many? 2. 2 and 4, 5 divided by 2. So here it will be 2.5 bond order. Now you are changing it to NO plus. If you are changing it to NO plus, then it will be what? It will be this way. NO plus means one electron you will be removing. Now it is a 14 electron system. So what will happen? This pattern will be just opposite. Remember this. For the 14 electron system, this will be the thing which will be changing, right? One electron, we are going to remove the electron from here because you are one electron, total six electron, no? So when it was NO, the bond order is 2.5, okay? And for bond order for NO plus will be electrons in a bonding will remain same 10 and anti-bonding it will be 4, right? One electron is not there divided by 2 which will be is equal to 3. Bond order has increased from 2.5, the bond order is increased to 3, right? What about magnetic character? It was a paramagnetic, it has changed to a diamagnetic. So option A itself is correct. Okay, let's check for the other options also. Let's check for the other options also. So N2 molecule. If it is N2 molecule, we know that the bond order for the N2 molecule is 3. Like we don't have to calculate. Let's do it for the magnetic character. We have to know the molecular orbital diagram. So this is N2. Nitrogen is 3 electrons this way. N2 is diamagnetic. So there is no change of the character from paramagnetic to diamagnetic. In N2 plus, what will happen is one electron will be less and this one electron you will be removing. So diamagnetic to paramagnetic, there is a change. Like bond order, you can also calculate later. So this is also wrong. O2, we know that it is bond order is 2. O2, we know that a bond order is 2. If it is O2 molecule, then it will be this way. Oxygen, oxygen, and oxygen. So bond order for the O2 molecule will be is equal to 2 because oxygen is bonded to oxygen by a double bond, right? It is more than 14 electron system. More than 14 electron system means uh, it will be this, right? So oxygen is having 4 electron. So total 8, 1, 2, 3, 4, 5, 6, 7, and 8, right? So this is a paramagnetic. If it is diamagnetic, then what will happen? Like if it is NO plus, means this will be plus and you will be removing one electron. Paramagnetic behavior is not changing to, it is remaining same. O2 to O2 plus, right? O2 to O2 minus. Now the change is this. O2 to O2 minus means I'll put this minus means usually O2 has 4 electrons. I'll make it 5 and this is like it is anyway paramagnetic, it is still remaining a paramagnetic, and bond order you can calculate. So the option this is also incorrect. So option A is correct for this. Again, this question is based on a molecular orbital theory. Um, Question asked is anion among the following, the molecule expected to be stabilized by anion formation. Okay, anion formation means if it accepts a electron, it will attain a negative charge and it will be stabilized. Like how we understand this by a anion formation? Like stability means what? If the bond order is increasing, increase in the bond order, higher the bond order. You can remember this. Higher the bond order, higher is the stability. right? Let's do it for the carbon molecule. I'll do it roughly. This is carbon, and this is carbon, and this is C2 molecule. How the bond, if there is a bond existing between a C2 molecule, then I should do it this way. Like, electronic configuration of the carbon is 1s2, 2s2, 2p2, right? Um, let's keep it like, anyway, let's keep this use outermost only. Let's use this outermost only. Mm, 2s I'll write this way, 2s. This is orbitals. This is bonding. This is anti-bonding. This is two electron. Here there are two electron. This is two electron, and here there are two electron. Right? P orbital. It is less than 14 electron system. Right? It is less than 14 electron system. So it will be less than 14 electron system means it is 2 1 2 1, right? 2 1 2 1. So there are how many electrons over here? Here there are 1 2 1 2. So 1 2 3 4. Bond order, we have to calculate a bond order of this. Bond order for this will be electrons in the bonding, like 1s will be there, but bonding anti-bonding there are same in the 1s, so let's not consider that, it will neutralize anyway. So bonding there are 2, and this 4, so it is 6 minus anti-bonding is 2 divided by 2, so it will be is equal to 2. So bond order over here will be 2, right? If it is C2 minus, means what I am doing is anion formation. This is minus, means I'm adding one electron. So where the electron will go to this, right? So this will become what? So bond order over here is going to be, bond order over here is going to be this way. Bond order for, this was for C2, C2 minus will be, it has become 7 now, bonding minus 2 divided by 2, which will be is equal to 2.5. So there is an increase in the bond order, right? So the correct option over here, I am getting it at first only, that is option A is correct. That C2 will lead to the anion formation because the bond order is increasing from 2 to 2.5. Okay, okay, let's check for the other molecules also. What is the trend? Fluorine. This is fluorine, and this is fluorine, and this is F2 molecule. So fluorine molecule will have 9 electrons, 7 electrons in the outermost shell. In the p orbital, it will be 5. 1, 2, 3, 4, 5, 4, 5. There are 10 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's take this. So bond order for the F2, we know it will be 1. Fluorine exists as a unimolecule. It will be fluorine, and the fluorine it will be 1. Let's calculate bond order for F2. Electrons in the bonding will be 2 and 6, 8, right? Like 1s is also there. I'm not considering for the calculation. 8 minus anti-bonding is what? This is 2 and this is 6. So which will be is equal to 1. If I am adding one electron, F minus if I am making, then there will be a electron over here. So bond order, it will be one electron extra over here, 8 minus 7 by 2. So bond order will be half for this 0.5. So bond order is decreasing. So F2 will never, F2 would never change to F2 minus because bond order is decreasing in that case because one of the electron will be added to the, so I will write bond order for F2 minus this. So there is a decrease from 1. So this is also not a correct. You can try for this and also for this because these are the incorrect option. So option A is the correct for this. Okay, here is the one more question which is based on the molecular orbital theory. You can see the trend, like most of the questions they're asking from the molecular orbital theory, like JEE Main 2019. This question was there, and the question asked is according to the molecular orbital theory, which of the following is true with respect to lithium 2 plus and lithium 2 minus? Lithium's electronic configuration is lithium is 1s2 2s1. If I want to form a lithium molecule, let's write for the lithium molecule. This is lithium 2 and this is lithium. So lithium is what? 1s and 1s I will write. Let's say this is 1s and this is 1s. There are two electrons over here. There are two electrons over here. This is 2s, right? This is 2s. One electron over here, one electron over here. So this is anti-bonding, this is bonding. So here there will be two electrons and here will be two electrons. Here this is anti-bonding, this is bonding. So 1 and 2. So the question asked is there are two things they have asked. They have said that lithium 2 plus and lithium 2 minus, right? Let's write it for the lithium plus. Lithium plus means what? Lithium plus means I will be removing one of the electron and this will be forming plus, and this is one electron I am removing. So how many electrons will be removed? One. So now I have to check the bond order of the lithium 2 plus, right? Electrons in the bonding is 2 and 3. 3 minus this is anti-bonding 2 divided by 2, which will be is equal to 0.5. Now what is a bond order for lithium 2 minus? Means over here I will make this minus, like lithium is this is lithium, this is lithium minus means what? I'm adding one electron, so this is 1 and this is 2. So what would be a bond order for this? What would be a bond order for this? So bonding electron there are 4, right? 1 2 3 4, and the anti-bonding this is 2 and this is 1, so this is 3 by 2, which will be is equal to 0.5. So both of them, lithium 2 plus and lithium 2 minus, we are having the same bond order 0.5 and 0.5. So option A, what it says, the lithium is unstable, and so this is same bond order, this cannot be true. Second cannot be also true, right? Both are unstable, this is also not true. Both are stable because their bond order is same 0.5, and they both are stable, both are equally stable. That is what it means. So option C is correct for this. If there were bond difference, like bond order difference was there, let's say lithium, this statement, first statement would have been true if lithium bond order was, lithium 2 plus bond order was higher than lithium 2 minus order, or lithium, sorry, lithium 2 plus bond order is less than lithium 2 minus, then first statement would have been correct, but both the cases bond order is same. So these are the questions of the molecular orbital theory from the previous years. So here there is another question which is based on a molecular orbital theory. According to the molecular orbital theory, which of the following molecule is not viable? Not viable means there shouldn't be any bond order. Bond order should be zero, right, for that molecule. So if we check for the helium 2 plus is this helium, helium and helium. Helium is this, right? So this is 1s, this is what the just electronic configuration, this is 1s, there are two electrons over here, there are two electrons, this is anti-bonding, this is bonding, this is helium, and here you can see that the bond order is 0, but they have asked for helium 2 plus. Helium 2 plus means plus 1 plus 1 plus 2 means I will be removing one electron from here, so there will be just this. So helium 2 plus, what will be a bond order of a helium 2 plus? It will be bonding there is 2 minus 0, in the anti-bonding it is 0, right? So that's why 0, which will be is equal to 1. Okay, this is viable, there is a bond order is 1. Helium plus 1, helium plus 1 means this, Helium plus 1 is this, right? So this is there are no electron over here, and here it is helium 2 plus 1. So this bonding is 2, anti-bonding is 0 divided by 2, which will be is equal to 1. So this is also viable. Like hydrogen 2 minus 1. Like hydrogen molecule, if it is existing, then it is this, and this. Right? Hydrogen minus means what? This is minus, one electron extra, and one electron over here. Hydrogen minus means there is if I want to find a bond order, I will write over here bond order of hydrogen 2 minus. Then it will be 2 minus 1 divided by 2, which will be is equal to 0.5. There is a bond order. H2 minus 2 means it is this H2 minus 2. Here also there is one electron. Here there is one electron. So bond order of H2 minus 2 will be 2 minus 2 divided by 0, which will be is equal to 0. Right? So this is not the viable molecule. This is not the viable molecule. You cannot have this molecule because bond order itself is 0. Okay, here is the question, very nice question, which was asked in JEE Main 2020. It was asked. Question says that if the magnetic moment of the dioxygen species is 1.73 Bohr magneton, right? What it is saying is that mu is equal to magnetic moment mu is equal to given as square root of n into n plus 2, right? This is what formula is of the magnetic moment, and what value what they have given is 1.73 Bohr magneton, right? So when this value will be Bohr 1.73, like n stands for a number of unpaired electrons. If n is equal to 1, if n is equal to 1, this would be 1 into 1 plus 2, that is square root of 3, right? Which is equal to 1.73, right? Square root of 3 comes to 1.73 when n is equal to 1, isn't it? So n should be is equal to 1. If n is equal to 2, just imagine this. If it is n is equal to 2, then this will be square root of 8, and isn't it? 2 into 2 plus 1. So 2 plus it will be square root of 8. So it will be 2.82. If the Bohr magneton value is 2.82, then number of unpaired electrons should be 2 in that case. So they have given that to be is equal to 1.73. So when it is 1.73 means we should have one unpaired electron. We should have a molecule where n is equal to 1 means number of unpaired will be is equal to 1. So let's check which of the molecule will have a, like all the parent atom is oxygen only over here. Oxygen is connected to the oxygen, and this is O2 minus. And since we have to find the pairing, like paramagnetic or diamagnetic, like 1s2, 2s2, 2p4. Here, pairing will take place in both the cases, bonding and the antibonding, bonding, antibonding. There will be a paired electrons for the 1s and the 2s. So we have to deal with only 2p. Like I will just solve for the 2p. 2p is this is 2p orbital, and it is oxygen is more than 14 electron system, so it is 1 2 2 1. Like if I am writing for the oxygen, then it will be 1 2 3 4, 1 2 3 4. So there are total 8 electron, 1 2 3 4 5 6 7 8. So we can understand that over here oxygen, if it is oxygen, then number of unpaired electron over here are 2, no? Right? Sorry, this is not O2, just O2. So directly you can say, no, that here also there is a O2, here also there is a O2, and here also there is a O2. So these all these are incorrect option. right? So let's check for O minus. O minus means what? One electron over here, and you will be adding one electron. If you are adding one electron, then it will have one unpaired electron, right? What is the meaning of O2 plus? O2 plus means if this is O2, if this is O2, then O2 plus will be what? Remove one more electron from one of the thing. So we are removing this. Sorry, we should remove this. Then I will remove one electron from here because there are seven electron. And again, there is one unpaired electron. So the option A is the correct one. So such type of questions, such easy, like we will say that this is a easy question if you know the molecular orbital theory and how to draw the diagram in a shortest way. You can solve this question quickly. So I'll end this class over here. Thank you so much.